Good morning all of you in today's session of class 11 chemistry. Actually what happened was that the scientific community, they were not in agreement with Bohr's atomic model because great energy go to a lower shell. But there was a issue that in that period of time some scientists had discovered that for subatomic particles it is not possible to locate the position and momentum simultaneously. So Bohr's model essentially focused on the radius of orbit, energy of orbit, velocity of orbit, etc. But according to certain evidence which the scientific community had received during that time, if you can locate the orbit exactly, there is no way you can comment on the momentum and vice versa. This was contrary to Bohr's model. So, and each orbital can accommodate maximum 2 electrons. So an orbital is a three-dimensional shape. What is that? I have drawn two arrows, one pointing up and one pointing down. So an electron, as everyone knows, has got a spin, and the spin is of two states. The up arrow denotes one state, and there are two spin states. So the up arrow, right? So the up arrow denotes the spin state S equal to half, and the down arrow denotes the spin state S equal to minus half. You have to understand one thing, that the spin of an electron is a three-dimensional spin. So it would be wrong to say that it is clockwise or anti-clockwise. They are just two opposite spin states. One is called plus half, the other is minus half, and they both are denoted by the symbol S. So according to the scientific community, suppose you are discussing hydrogen. So hydrogen has got one shell. As per Bohr's model, it has got one shell. So N will be 1. Now according to orbital concept, there are two subcategories, like between the shell number and the fact that electron can be either plus half or minus half. So between these two, there are two more numbers which completes the location of an electron. So the shell is one of them, the other is the spin of the electron, but there are two more numbers. So the first one is called azimuthal quantum number. Azimuthal quantum number, symbol is L. The second one is called magnetic quantum number, symbol is M. Now azimuthal quantum number, it starts from 0 and goes up to n minus 1, and magnetic quantum number starts from minus L and goes up to plus L. So between shell number and spin of electron, you have azimuthal quantum number and magnetic quantum number. Now azimuthal quantum number, it is written 0 to n minus 1. So when n is 1, then it will be just 0. And there is a thing, if you remember, that in Bohr's model, the shells have got a nomenclature. When n is 1, it is called K. When n is 2, it is called L. When n is 3, it is called M. When n is 4, it is called N. So similarly, in azimuthal also, when it is 0, it is called S. When it is 1, it is called P. When it is 2, it is called D. When it is 3, it is called F. So azimuthal quantum number nomenclature is SPDF or 0, 1, 2, 3. Now if the shell number is 1, the azimuthal quantum number can only be 0 and magnetic quantum number can only be 0. So we say like this: hydrogen has only one electron, the shell is 1, the azimuthal quantum number is S. Now when magnetic quantum number is 0 and azimuthal quantum number is also 0, when both are 0, then we say that L and M are synonymous with each other. So if you say 1s, that means the M has already been included in this, because M and L both are 0. So 1s is the location and there is one electron, so you write 1s1. So the electronic configuration of hydrogen is 1s1. Now suppose you are going to discuss helium. So there was a scientist called Pauli. He said that inside an orbital, the two electrons will always have opposite spin. So if one has a up spin, the other will have a down spin. This is called Pauli's principle. The two electrons in an orbital cannot have the same spin. So this is up, this is down, and the configuration will be 1s2. Then we go to lithium. Now what happens is that lithium atomic number is 3, so you will have 1s2. Now your orbital is over, so you have to start a new orbital. So you know that when n is 1, L can only be 0, so that's it. Now you go to shell number 2. In shell number 2, the value of azimuthal number can be anything from 0 to 1. So it can be either 0 or 1. So if it is 0, it is 2s, and if it is 1, then it is 2p. But if the azimuthal quantum number is 1, then the magnetic quantum number can be anything out of -1, 0 and 1. So we don't have to worry about that right now. Let's just focus on the third electron of lithium. So lithium's configuration is 1s2, 2s1, right? Then let's move on to beryllium. So beryllium will be again 1s2, and there will be another electron, so it will be 2s2. So this will be beryllium, right? Now let's move on to boron. So boron, it will be 1s2, and after that it will be 2s2. Now there is a 2p orbital. So because you know that boron has atomic number of 5, so the next electron will come here, right? So the atomic number of boron is 5, and the next electron is coming over here. Now you know that after boron the next element is carbon. So for carbon, should you put the 6th electron of carbon, should you put it as a pair with this, or should you put it in this vacant space? So for that there was a scientist, so just like Pauli, there was a scientist called Hund. So Hund said that you cannot pair electrons unless every orbital is singly filled. So there is a single electron here, there is nothing here, there is nothing here. So unless all of them are singly filled, you cannot start doing para. So according to Hund's rule, in case of carbon, the 6th electron will come here, right? And then for nitrogen, the 7th electron will come here. Then for oxygen, you can start coming back and pairing up. So oxygen's 8th electron will be here, and fluorine's 9th electron will be here, and neon's 10th electron will be here. So this will be your homework. You have to, I have done up to boron. So carbon, nitrogen, oxygen, fluorine and neon. You will have to write the configuration. That will be your homework, right? You will have to do the configuration of carbon, nitrogen, oxygen, fluorine and neon. That's your homework, right? So that will be all for this session. I'll end the session now. Bye all of you. Earlier I gave some money to one company, absolutely useless, and they are these. Yeah. Now I don't need any person. Good morning all of you. In today's session of class 12 maths, we are going to discuss differentiation of inverse trigonometric functions. So I'll be telling you some formulas. So dy dx of sin inverse x is 1 by root 1 minus x square. Dy dx of cos inverse x is minus 1 by root 1 minus x square. So dy dx of tan inverse x is this. Dy dx of cot inverse x is this. So dy dx of sec inverse x is 1 by x root x square minus 1. And dy dx of cosec inverse x is minus 1 by x root over x square minus 1. So these are the 6 formulas of differentiation of inverse trigonometric functions. Now, so based on this, I am now giving some homework as always. So root over sin inverse x square e to the power tan inverse x cot inverse 1 plus x by 1 minus x then x square cos inverse 1 minus x. So these are the homework questions. First one, differentiate root over sin inverse x square. Second one, e to the power tan inverse root x. Third one, cot inverse 1 plus x by 1 minus x. And fourth one, x square cos inverse 1 minus x. So these are the 4 homework questions from differentiation of inverse trigo functions. You can submit your homework by 9 p.m. tomorrow. That will be all. I'll end the session. Bye all of you. Okay, ma'am, I start.